Good evening, and today we are going to continue the quadratic equations. We have already seen the problems, and we are continue that with the theory of equations. What makes the basic difference between the quadratic equations and theory of equations? In the quadratic equations, the degree of the equation is 2, and in the theory of equations, we are going to discuss the general degree like nth degree polynomial. Nth degree polynomial means if it is greater than 2, like it may be third degree, it may be fourth degree, it may be fifth degree, and so on, it may be nth degree. So for that purpose, the basic thing what you have to understand here in theory of equations is this. And if you take the general form to the polynomial equation, you all know, but I want to revise that, is f of x is equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus and so on a n is the general form of the nth degree polynomial expression, I say, because it is not equated to 0. If it is equated to 0, we call it as the equation. It is an nth degree polynomial equation. Nth degree polynomial equation. This n may be 1, 2, 3, 4, 5. If n is 1, it is a linear polynomial of first degree. If n is 2, it is said to be quadratic equation or second degree polynomial equation. If n is 3, it is a cubic polynomial or third degree polynomial equation. If n is 4, it is said to be fourth degree polynomial equation, or we can call it as fourth degree polynomial equation, or n is equal to 5, it is fifth degree polynomial equation, and so on like that. So if the power of n is, the power of x is n, and n is any integer, any natural number, n belongs to n, n belongs to n, then how many roots this nth degree polynomial has? It has how many real roots nth degree polynomial equation has? It will have maximum of n roots. It will have maximum of n roots. N real roots, I must say. N real roots. And including all roots, it will have n roots. Including all roots, it will have n roots. Some may be equal roots. Some may be equal roots, that is repeated roots. Like if you have 1, 1 as roots of any polynomial, like 2, 3, 4, there is a fifth degree polynomial, then it has 2 roots equal. Then in this case, we call it as 4 roots only, because 2 roots are equal. That is why I mentioned the maximum number of n real roots will be there. And if you want all the roots means maybe complex roots, maybe complex roots. Complex roots, if they are added to real roots, then the total number of roots will be n. Roots will be there for an nth degree polynomial. So what I'd like to tell you here in this case now is this. That is, if alpha 1, alpha 2, alpha 3, alpha 1, alpha 2, alpha 3, so on alpha n are roots, then I will form the polynomial equation, nth degree polynomial equation like this. I will divide throughout with a naught because I want to make the leading coefficient 1. Leading coefficient 1. So I will divide throughout with a naught. That becomes a1 by a naught into x power n minus 1 plus a2 by a naught into x power n minus 2 plus and so on. An by a naught is equal to 0. Now after making this like this, its roots are, I have taken to be alpha 1, alpha 2, alpha 3, and so on alpha n. Therefore, it can be written as x minus alpha 1 into x minus alpha 2 into x minus alpha 3, and so on x minus alpha n. So this is how you can now understand the relation between the roots and the coefficient. You can understand the relation between the roots and the coefficient. Between the roots means if it is x into x into x into so on nx here, that will give you x power n. That will give you x power n. And if you leave it and if you multiply this, it will give you x power n minus 1. Similarly, if you leave this and multiply x power n minus 1. So like that, if you compare some of the roots, first one, alpha 1 plus alpha 2 plus alpha 3 plus so on alpha n is given by minus a1 by a naught. This is what you have to understand. I'll take an example and I'll explain you more about this. And similarly, alpha 1 alpha 2 plus alpha 2 alpha 3 plus so on alpha n minus 1 alpha n is nothing but a2 by a0. What does it mean? Taking the roots one at a time, the sum of the roots taken one at a time, the sum of the roots taken two at a time, the sum of the roots taken three at a time. Like that, you will finally get sum of the root, product of the root, take sum of the roots taken all at a time. Sum of the roots taken all at a time means finally going on like this, you will get the product of the roots alpha 1, alpha 2, alpha 3, so on, alpha n as minus 1 whole power n into a n upon a naught. These are the relations between the root and the coefficient. Understand that first. And if you want to have the short form of writing the equations, when the roots are known to us, follow this carefully. That is, I'll write for your better understanding x minus alpha 1 into x minus alpha 2, which is nothing but x square minus of alpha 1 plus alpha 2 into x plus alpha 1 alpha 2. Sum of the roots, product of the roots. You know that very well, that it is minus b by a and it is c by a. You know that. We have learned that. And similarly, if you take x minus alpha 1 into x minus alpha 2 into x minus alpha 3, it will be x into x into x, x cube minus sum of the roots into the degree less than that is x square plus taken two at a time, alpha 1 alpha 2 plus alpha 2 alpha 3 plus alpha 3 alpha 1 into 1 degree less than this x minus product of the roots alpha 1 alpha 2 alpha 3. So like that, when you want to multiply three factors like this, you can straight away write the step like this. And similarly, I'll make you understand for 4 and then we'll proceed to the problems. X minus alpha 1 into x minus alpha 2 into x minus alpha 3 into x minus alpha 4. Then I want to write the multiplication of this x power 4 first. And then x cube coefficient will be sum of all the roots alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 into x cube plus sum of the roots by taking two at a time. Next, it is alpha 1 alpha 2 plus alpha 1 alpha 3 plus alpha 1 alpha 4 plus alpha 2 alpha 3 plus alpha 3 alpha 2 alpha 4 plus alpha 3 alpha 4 into x square. What I'm doing here, I'm writing different combinations of alpha 1 alpha 2 alpha 3 by taking two at a time, which will give you the coefficient of x square, and minus of next by taking 3 at a time, alpha 1 alpha 2 alpha 3 plus alpha 1 alpha 2 alpha 4 plus alpha 1 alpha 2 alpha 3 is finished, alpha 1 alpha 2 alpha 4 is finished, next alpha 2 alpha 3 alpha 4 into x cube. This is x cube, x square, x power 4, x cube, x square, next is x plus taken all at a time, alpha 1 alpha 2 alpha 3 alpha 4 is equal to 0. This is, if it is 0, it is a fourth degree polynomial equation. If nothing is written, it is simply a polynomial expression, fourth degree polynomial expression. So when you want to multiply three factors or four factors, then you can simply apply this, and I will show you very simple. This one, that's what I have shown here. Sum of the roots here, product of the roots here, sum of the roots here, sum of the roots taken two at a time here, sum of the roots taken all at a time here is nothing but the product of the roots. Similarly here also the same. So whenever you want to multiply three equations, write them directly like this, like three factors. Whenever you want to multiply three factors like this, write it like this, x cube. You'll get directly x cube. Sum of the roots 1 plus 2 plus 3 is nothing but it is 6x squared. Next, sum of the roots by taking two at a time, 1 into 2, 2, 2 plus 3, 5, 5 plus 6, 11, 11x minus 6. That's all. Within one step, you can write the multiplication like this if you understand the relation between the coefficients and the roots. These are the roots here. So this is all about the relation between the coefficient and roots. And we already discussed that the irrational roots always occur in conjugate pairs if the coefficients are rational. What does it mean? If a plus root b is a root, then obviously a minus root b will be definitely a root if all the coefficients are rational. Remember that. Similarly, if a plus ib is one root, then a minus ib will be another root. Definitely. It should be. If all the coefficients are real. If all the coefficients are real. So we will make use of these properties and we will go through the problems. Now, see the first problem there. The equation of lowest degree with rational coefficients having a root 2 plus root 3 plus I, where you all know I stands for the imaginary root. I is an imaginary root whose value is root over minus 1. You all know that. So the equation of lowest degree with rational coefficients. What does it mean? One root is given to be root 2 plus root 3 plus I. Okay, let me take this as x. And what should be your understanding first? When it is irrational, when it is irrational, then you will have the roots in this way. This is root 2 plus root 3, let me take, and plus I becomes minus I. This is one more root. Similarly, root 2 minus root 3 plus I is one root. Root 2 minus root 3 minus I is another root. Similarly, minus root 2 plus root 3 plus I is one root. And minus root 2 minus root 3 minus I is another root. So, if you're going on writing like this, you will get simple equation. So, for your understanding, I wrote all of them, but you understand in this way. It will have plus or minus, it will have plus or minus, it will also have plus or minus. So, what do you understand by this one? The combination can be written. Permutations. This permutations and combinations, this can be written in two ways. This is two ways, this is two ways. All these operations can be performed in 2 into 2 into 2. It is 8 different ways. That means you will be getting 8 different roots for this one. 8 different roots for this one. So if you understand that carefully, then if you get 8 roots, the equation must be of 8th degree. Equation must be of 8th degree. So if you see the options there, first option is consisting of x power 4, second option also x power 4, third option also x power 4. The last option is only x power 8. So by closing your eyes, you can simply say that that is the answer. But in that question, if all are given to be x power 8, if all are given to be x power 8, then what is to be done? Then in such a case, what you have to do, you have to eliminate the square root and as well the imaginary part by squaring or finding the power 4, finding power 6, finding power 8, like that. So briefly, I'll explain you how to do that. Now, this is root 2 plus root 3 is equal to x minus I. Okay, x minus I. Otherwise, you take that I only that side and write it in this way. Minus x is equal to minus I. Then what happens? If you square it, it will be in the form of a plus b plus c whole square. So, for the sake of easiness, let me write it as x minus I, otherwise x minus I. Then squaring on both sides, it is 5 plus 2 root 6. 5, 2 plus 3, 5 plus 2 root 6 is equal to x square minus 2ix plus I square. Plus I square is nothing but minus 1. So, what happens here? It is 5 plus, this is plus 1, 6 plus 2 root 6 is equal to x square minus 2ix. X square minus 2ix. Then what you have to do here, you have to square it to remove this I. So, for that purpose, 6 plus 2 root 6 minus x square whole square is equal to minus 2ix whole square. Minus 2x whole square, 4i square is nothing but minus 4x square. Okay, now, if you write this, expand this, is power 4. To remove this root 6 again, you have to square this power 4 again. Here, this x square whole square is there, x power 4 you will get. So, x power 4 again squaring. Why should we square it? Because still I is eliminated. You have I here, eliminated. You don't have I in this one. But you have root 6 in this one. But what do we need there? Lowest degree with rational coefficients. Rational coefficients means the coefficient should not be contain root. It should be rational. So for that purpose, again, after writing this, you will take this term and you will square it. So again you have to square it, but the highest power is x power 4 here. If you square it again, you'll be getting x power 8. So this is a procedure like how you have to find the lowest degree rational coefficients equation when the roots are given to be root 2 plus root 3 plus I. This is a procedure I have explained you. So from this one, what do you understand now? Simple understanding. Whatever the equation is to be written, and you have to always take plus or minus 4 the rational irrational roots, and even for imaginary complex roots also you have to take plus or minus, like that 8 different roots will be got, and by multiplying all of them or by removing these roots and I, you will be finally getting 8th degree polynomial equation. That's what it is. Let's go to the next problem. If 1 root of 3x power 4 minus 10x cubed plus 4x square minus x minus 6 equal to 0 is 1 plus root 3i divided by 2, then the roots are, when one of the roots is given to be 1 plus root 3i divided by 2, other root will be obviously 1 minus root 3i by 2. Because what I said here, you can clearly see that all the coefficients there are rational only. 3, minus 10, 4, minus 1, minus 6. They are all rational, and because they are rational, if one of the roots is real, one of the roots is a complex root, and you must have its conjugate as also a root. So what you get here, simply the roots must contain 1 plus or minus root 3i by 2. So if you see the options, first option contains 1 plus or minus root 3i by 2, and second option also contains 1 plus or minus root 3i by 2, third also, fourth also are containing 1 plus or minus root 3i by 2. So in such a case, what to do? Simple. Whenever this type of questions are given, simply verify the options. I'll show you what to do that, how to do that. Not to miss the concept, I'll explain to that. But here what you understand, whenever the roots are given to be minus 11 by 2, 3 by 5 in the first option, in the second option 3 by 2 minus 3 by 2, in the third option minus 2 by 3 4 by 5, and fourth option minus 2 by 3 3, then in such a case, if it is a root, definitely it must satisfy the equation. If it's a root, definitely it must satisfy the equation. So what we do, we pick out one root from the option and we substitute that in the equation. If it's satisfied, then definitely that will be the root. So what we do, we cannot extend that. We should not take more and more time in the verification also. If you substitute first time 3 by 5, if it satisfies, that will be the answer. If 3 by 5 is not satisfying, then you have to go for the second one. In the second one, you have 3 by 2. If 3 by 2 satisfies, that will be the root. If 3 by 2 is not satisfied, then come to the third one. Third one will be 4 by 5. If you substitute that, if it satisfies, that will be the answer. If all the 3 are not satisfying, no need to check for fourth one, because you will have single correct answer in MSET. Okay, so for that one, after verifying all the 3, then simply we say that if 3 or all the 3 are not satisfying, then simply we say that fourth option is the answer. So, but to solve this equation, then what to do? Simple. Then you write like this: the equation with these roots, the equation or the factor with these roots is what? X square minus sum of the roots plus root 3 minus root 3 will be getting cancelled. 1 by 2 plus 1 by 2, 1 minus x, plus product of the roots 1 plus 3, 4 by 2, it is 2, is equal to, it is the factor. What I want to make you understand, this must be the factor of the given equation. So 3x power 4 minus 10x cube plus 4x square minus x minus x. If you divide this with this one, the division process, do you remember? You must remember, because you have learned in your lower classes itself. So what we do, you multiply with 3x square, then it will be 3x power 4 minus x into minus 3x square minus 3x cube plus 6x square. Subtract minus 7x cube minus 2x square minus x. So again minus 7. This should be minus 7x, and it will be minus 7x cube minus plus 7x square and minus 14x, and it will be, this will be getting cancelled, and you'll have minus 9x square plus 13x. Is it correct or not? Subtracting plus 13x. So what should it be? Plus 6. This is minus 6. It's brought down here, minus 6. So what should it be? Minus 9. So minus 9x square minus 9x. Somewhere it has gone wrong. Let us check it out. X square, 3x square, 3x power 4, and it is minus 3x cube plus 6x square. Subtracted. So minus 7x cube, and it is minus 2x square, and minus x is brought down, and again it is to be multiplied with minus 7x. So minus 7x means minus 7x cube, and it is plus 7x square. Is correct only. And minus 14x. Minus 14x is this one. If you subtract, you'll be getting minus 9x square. It's correct only on subtraction, and it is 13x, and minus 6 is brought down. Then it must, but that means you must get 0 as the remainder, because it is given to be a factor. 0 must be the remainder. So that's what I'm seeing here. This must be getting cancelled, and finally you must get 0, and then you'll get the factor, other factor. So let us check the equation. 3x power 4 minus 10x cube plus 4x square minus x minus 6. It is correct only. Let us check this equation. X square minus sum of the roots. It is 1 plus 1 by 2 minus 1. Correct only. And product of the roots, 1 minus 3i square. 1 plus 3, 4 by 2. It is 2. So x square minus x plus 2. So we divided with this one. So 3x square into x square, 3x power 4, and 3x square into minus x minus 3x cube, correct only, plus 6x square. Subtracted, and minus 7x cube, it is minus 2x square minus x. So if you subtract this, you are getting minus 9x square and plus 13x minus 6. So what we're doing, we're multiplying with minus 9x square, and it is plus 9x. You're not getting it cancelled. It must be. It must be. Otherwise there should be something wrong in the simplification or in the question. So it is minus 18 you're getting. Minus 18. So if you subtract this, you're getting this cancelled, of course, but this must also get, you must get 0, because if it is a factor. So let us check the question. If one of the root of 3x power 4 minus 10x cube plus 4x square minus x minus 6 equal to 0 is 1 plus root 3i by 2. If it is 1 plus root 3i by 2, other one will be 1 minus root 3i by 2. 1 minus root 3i by 2. That's what we have written. It's correct only. So if you find the roots of it, minus 1 plus or minus root over b square minus 4ac. b square minus 4ac means minus 1 minus of it is b square 1 minus 4ac. That is somewhere it is. So let us find the roots of it. 1 plus or minus root over b square minus 4ac. 4 into 1 into 2 minus 8. b square minus 4ac. 4 into 2, 8 by 2. This is what you are getting wrong. That means this expression is wrong somewhere, because you are not getting these roots here. Minus b plus or minus root over b square minus 4ac. 4 into 2, 8. You must get root 3 here. Root 3 here. So you must get 9 there. So there is a mistake in this one. Let us check it out. Let us check it out. I'll do in this way. I'll explain you in another way. This is x. I'm writing it in this way. 2x minus 1 whole square is equal to root 3i whole square. Root 3i whole square is 3i square. 3i square is nothing but minus 3. So it is nothing but 4x square minus 4x minus 4x plus 1 plus 3 plus 4 equal to 0. This must be the equation. Somewhere we have gone wrong there in writing the equation there. So what I did here, I have taken this as x, and this I is eliminated. like what? It is 2x minus 1 whole square is equal to, this is root 3i whole square is nothing but 3i square is nothing but minus 3. So 4x square minus 4x plus 4 equal to 0. It's clearly now minus b plus or minus root over b square, that is 16 minus 16 minus 16 into 4, it is 64. 16 minus, then it will be correct. So what we do here, 4x square minus 4x plus 4 now. That's what we have gone wrong. Okay. Now, if you divide this, you'll get the other factor. Okay. So this is very well known to you, like it's very well known to you, the division part. Okay. So what we have to do here, briefly, what we have to do here, the roots are very much given there, 1 plus root 3 I by 2, and the other root will be 1 minus root 3 I by 2. By taking those two, I wrote the equation, and you can do in this way also. This is considered as x, and I want to eliminate I here, that is why cross multiply 2x minus 1 whole square is equal to root 3 I whole square is nothing but minus 3. Simplifying this, 4x square, it is minus 4x, it is plus 1, and plus 3 is plus 4 equal to 0. If you find the roots of this, then you will get the roots like this, 1 plus or minus root 3. So after getting this, simply divide this factor, simply divide the entire equation with this factor. Then you will get the other factor, and if you solve it, you will get the roots. Simple equation. Okay. So follow that method to get the other roots. Otherwise, simply verify the options. Okay. Let's go to the next one now. It is if the roots of 27x power 4 minus 195x cube plus 494x square minus 520x minus plus 192 is equal to 0 or in GP, then the roots are or in GP. It is given to be GP. Then what are the roots? Simple. You don't take more efforts there. Simply verify the options. What are the which option is satisfying the equation? Then you can proceed with that one. But to understand the method, I am telling you how to proceed. See, it is a fourth degree equation, and the roots are given to be in AP. So what I do here, I'll take the roots as alpha divided by beta square, comma, alpha divided by beta cube, comma, alpha by beta, comma, alpha beta, comma, alpha beta cube. If you follow this carefully. Why I have taken like that? If you divide, that's GP means second term upon first term must be equal to third term upon second term, must be equal to fourth term upon third term. You must understand that. So if you divide this one, alpha getting cancelled, and it will be, what is the ratio here? Alpha divided by beta divided by alpha divided by beta cube, alpha getting cancelled. Beta square is the ratio. Here also beta square is the ratio. Here also beta square is the ratio. So what to do here? You have or in GP. In fact, what you have to understand there, in that one, the equation given, let me write the equation. It is 27x power 4 minus 195x cube plus 494x square. 494x square minus 520x plus 190 equal to 0. And it is given that the roots are in GP. So if you want to take the roots particularly, then you have to take it as alpha, beta, gamma, delta. You must take 4 roots. And you have to apply the condition for GP and all. But what we do, we take the roots in this way. What happens? The 4 terms will be reduced to 2 now. One is alpha and one is beta. So if you find out only the value of alpha and beta, then you can write all the roots. So what we do here, simply the product of the roots. Why should we take like this? What is the advantage by taking like this? What is the advantage by taking like this? By taking like this, if you multiply all this, alpha by beta cube into alpha by beta, into alpha beta, into alpha beta cube. What happens? Beta cube, beta cube, beta, beta, and the product of the roots is 192 upon 27. Understand now? So alpha power 4 is equal to 192 upon 27 is nothing but you will get 9 3 is 27 and 6 3 is 18, 6 4s. So it will be 64 upon 9, which is nothing but alpha is nothing but it is square root of, if you take alpha square, it is nothing but 8 upon 3, and if you take alpha, it is root 8 upon root 3. What is happening here? You are getting one value directly if you consider like this. Then later on, that means we have made use of the product of the roots here. Alpha is equal to root 8 by root 3, and after that we write another relation. What is another relation? What should be another relation? We will write the sum of the roots and we will make use of the coefficient here. I have explained in the beginning itself. That is the relation between the roots and the coefficients. Roots and the coefficient. Sum of the roots is nothing but 195 upon 27 minus a1 by a0 minus a1 by a0. Similarly, by taking 2 at a time, by taking 2 elements, you will multiply these two, or these two, and these two. Like that, you can write another relation. But in this one, alpha value is very much known to us. We will substitute that alpha value. You will get another equation in terms of beta, and you will solve for beta to get its value. After getting alpha and beta, we will substitute it in this one and to get the roots there. So if you see the options there, the remaining all are integers except the third one, it is 8 by 9, 4 by 3, 2, 3. And with the use of this, you can solve the equation to get the roots. Okay. Next one, please. Next one is, if alpha, beta, gamma are the roots of x cube minus px square plus qx minus r is equal to 0, then alpha plus beta whole power minus 1 plus beta plus gamma whole power minus 1 plus gamma plus alpha whole power minus 1 is needed. What is this equation given? This one is the equation given. What are its roots given? This is to be find out anyway. You keep it like this first. We'll think of it. This is needed, and its roots are given to be what? Alpha, beta, gamma, isn't it? Then we need 1 by alpha plus beta plus 1 by beta plus gamma plus 1 by gamma plus alpha. It is a standard method, understand. If you see this one carefully, it is nothing but 1 upon alpha plus beta, 1 upon beta plus gamma, 1 upon gamma plus alpha. That is, sum is needed there. This one is this equation. So what do you understand from this one? It is nothing but sum of the roots form, of course. Sum of the roots form, but here the roots are not alpha, beta, gamma, but 1 upon alpha plus beta, 1 upon beta plus gamma, 1 upon gamma plus alpha. So what I do now, I will convert this equation. In such a way that its roots, the resultant equation will have these roots. The resultant equation will have these as roots. How to do that? This is an important method. Follow this carefully. So what we do, I will take 1 upon alpha plus beta as y. You can take it as x also, not a problem, but x is already used there. That is why I am taking y, and finally you can convert that y as x also, not a problem. Now what is my task here? Because these are the roots, they must satisfy this equation. It's clear for you. Now what I am doing, I want to make use of the relation between the coefficients and the roots. I want to make use of the relation between the coefficients and roots. So for that purpose, to write the sum of the roots here, I need gamma. So gamma added. 1 upon y plus gamma. What should be sum of the roots in this case? Sum of the roots is nothing but minus of minus p upon 1. It is nothing but p, I say. Do you understand what I'm saying? P. Then 1 upon y plus gamma. Follow this carefully, please. It's a very interesting method, and if you follow this carefully, you can straight away solve the equation very easily. So 1 upon y is nothing but p minus gamma. So y is nothing but, and I want gamma here. I'll do like this. 1 upon, I'll take 1 by y to that side. P minus 1 by y is equal to gamma. What is my interest here? My interest is, I want to get an equation in terms of y. Why? Because y is nothing but 1 by alpha plus beta. If I get an equation in terms of y, then its roots will be 1 by alpha plus beta, 1 by beta plus gamma, 1 by gamma plus alpha. So for that purpose, what I'm doing, I'm expressing gamma in terms of y. P is given in the equation itself. So from this one, what is gamma here now? Py minus 1 upon y is nothing but gamma. Now what we do, what is gamma? Gamma is the equation. The gamma is the root of this equation. Gamma is the root of this equation, and hence it must satisfy this equation. So if you substitute the value of gamma in this one, what will you get? So you will get py minus 1 upon y whole cube. How do you write that? Because gamma is a root of this equation. I've got gamma in these terms. Instead of gamma, if gamma is replaced here, instead of x you will get gamma, but I am replacing gamma with this one. Py minus 1 upon y whole cube minus p into py minus 1 upon y whole square plus q into py minus 1 upon y minus r is equal to 0. So what do you understand by this one? Simple. What do you understand by this one? It is nothing but py minus 1 whole cube divided by y cube minus p into py minus 1 whole square divided by y square plus q into py minus 1 upon y minus r equal to 0. If you take LCM, it will be ry cube, this one, ry cube. Otherwise, take LCM and cross multiply, that becomes 0 anyway. Py minus 1 whole cube, p cube y cube minus 1 minus 3p square y square plus 3py is expanded minus py into p square y square plus 1 minus 2py plus qy square into py minus 1 minus ry cube is equal to 0. So what is that you have got finally? This is the equation. But what we need is, we need only sum of the roots. For sum of the roots, what is the formula to be applied? Sum of the roots minus a1 by